So as we continue the logic, we want to talk about predicates and quantifiers. So if we think about statements like he is vice president and x plus y is greater than 10. So when you initially see those statements, you can't make a decision about whether they're true or false because you don't know who the he they're referring to is, or you don't know what the values of x and y are. And so a predicate is a statement that involves a variable. And the thing about a predicate is that it becomes a proposition when you give a value for the variable. So if I say Jack Black is president, so in our first predicate, the variable is he. If I named Jack Black as the he, then we could determine whether that was a true statement or a false statement. In the second one, we have two variables, x and y. If I told you x was 6 and y was 7, then you could determine whether that statement is true or false. So it becomes a proposition when you give a value for the variable. To write a predicate, we use a capital letter and then we put the variable inside the parentheses. So if we talk about the x plus y greater than 10, it could be the statement q of xy would be the value, would be the name of my predicate, and then the statement that we use would be x plus y is greater than 10. So if I asked you whether q of 2 comma 3 was true or false, then you would say is 2 plus 3 greater than 10? False. But if I did q of 6 comma 7, you would look at is 6 plus 7 greater than 10? True. Another way to make a predicate into a proposition, give it a truth value, is to use a quantifier. And so a quantifier is a way of saying how many of the values of the variables we're considering. We're going to talk about two different quantifiers. We're going to talk about the universal quantifier and the existential quantifier. So this considers the predicate over many values, called its domain. So the universal quantifier is this upside down A. And when you think about a universal quantifier, you want to think about the words for all, or every, or each. Okay? And the existential quantifier is this backwards E. And you think about the words there exists, or for some, or at least one. So if I give an example, I could say for all integers x, x squared is greater than or equal to 0. So my predicate was that x squared was greater than or equal to 0, and I quantified it by saying for all integers. In the second example, I could say some student in the class has a birthday in July. So my predicate is a student has a birthday in July, and my quantifier is some. So what you want to think about is how would you show that for all x, q of x is true? Or how would you show that for all x, q of x is false? So when you have the universal quantifier, how would you show for all x, q of x is true? You would do that by checking every value in the predicate and make sure it's true. That's really hard, right? Because if the domain or the values come from all the integers, you'd have to check an infinite number of things. Okay, so how would you show that for all x, q of x is false? You find 1 it doesn't work for. Or you find one value that makes the predicate false. When we say it doesn't work, we mean make the predicate false. Okay, so how do you say there exists a q of x is true? Or for some x, q of x is true? Well, you find 1 that makes the predicate true. Just 1. There could be lots, but you just need 1. So how do you show that there exists q of x is false? So you have to show that it's false for every value in the predicate. So go work through an example of this and look at these predicates and see whether things are going to be true or they're going to be false, so that you can see like how these things work.